So in the previous video, I have discussed about the polymer concrete. So in this video, here I am presenting the application of fiber reinforced concrete. It is also one of the special concrete normally used for some special purposes. Yes. So let us see some history part of this fiber reinforced concrete. The use of fibers goes back at least 3,500 years when straw was used to reinforce sun-baked bricks in Mesopotamia. Then horsehair was used in mortar and straw in mud bricks. So after that, asbestos fibers were used in concrete in the early 1900. In the 1950s, the concept of composite materials came into picture. At that time, the steel, glass, and synthetic fibers have been used to improve the properties of concrete for the past 30 or 40 years. Yes. Then research into new fiber reinforced concrete continues even today. Then the introduction part. Concrete containing cement, water, aggregates, and discontinuous, uniformly dispersed or discrete fibers is called fiber reinforced concrete. So we can use lot of fibers. So that may be only in the solid forms. That fiber should be in the solid forms. That fibers are being added at the time of preparing the concrete, and therefore the behavior of concrete, strength of concrete, everything are being improved, enhanced. Yes, it is a composite obtained by adding a single type or a blend of fibers to the conventional concrete mix. Then fibers can be in form of steel fibers, glass fibers, natural fibers, synthetic fibers, etc. So we can use any one of the fibers, and we can discuss further the different types of fibers when it is added into concrete, and how the concrete changes its behavior while adding these all fibers in it. Why fibers are used? The main role of fibers is to bridge the cracks that develop in concrete and increase the ductility of concrete elements. There is considerable improvement in the past cracking behavior of concrete containing fibers due to both plastic shrinkage and drying shrinkage. Of course, so once the fiber is nothing but a continuous solid material like the aggregate, and therefore it is highly and arresting the cracking part. They also reduce the permeability of concrete and thus reduce bleeding of water. Of course, it is acting as a film. It is acting as a layer to arrest those things. Some types of fibers produce greater abrasion and shatter resistance in concrete. It imparts more resistance to impact load. You see that the here we see that the plain concrete curve is simply when it goes some ultimate load. Once it fails, then the load reaches into zero, stress reaches into zero. But in case of once if we use the FRC fiber with high fiber volume, and it behaves as a it behaves completely changed into ductile nature. You see that the plain concrete, the curve corresponding to the stress strain curve of the plain concrete, which shows the concrete is a pakka brittle material, whereas once if you add the volume of the fiber content into the concrete, its behavior changes into ductile. Okay, so if you add more volume, then its behavior completely changes into brittle. If we add low fiber volume, its behavior is in between brittle and ductile. Then you see that while breaking the member in a simple plain concrete, it is simple brittle failure, and it happens very sudden in nature. But if we use the fiber concrete, a member which is casted with the fiber reinforced concrete, you see that its nature of fail is highly ductile in nature. Okay, its fail is ductile in nature, and therefore the sudden failure cannot be attained. Okay, so it is the one of the major advantages when compared to other concrete, normal concrete. Then let us see some different types of fibers: steel fibers and the glass fibers. So these are all the some of the photo images of these steel fibers and the glass fibers. Then carbon fibers, cellulose fibers, then synthetic fibers, especially the polypropylene fibers, the nylon fibers, the natural fibers. Nowadays natural fibers, the coir is coir is being used as the one of the fiber in the fiber reinforced concrete. Then hay. So these all things are some types of fibers. So if we use these steel fibers, normally its aspect ratio of 32 to 50. First we must know about the what is aspect ratio. It is nothing but the length to diameter or thickness of the fiber, a single fiber, which is said to be the aspect ratio. Then diameters vary from 0.25 to 0.75 mm. So whatever the steel fibers that we are going to use in the concrete, its diameter vary from 0.25 mm to 0.75 mm. Then the steel fiber, once if you use the steel fiber into concrete, it gives high structural strength. Then the reduced crack widths and control the crack widths lightly, thus improving durability. Then improve impact and abrasion resistance, and then used in precast and structural applications, highway and airport pavements, refractory and canal linings, industrial flooring, bridges, decks, etc. Then if you use the glass fibers, it is also having high tensile strength. It is about 1020 to 4080 Newton per square. A glass fiber itself is having its tensile strength about 1000 to 4000 Newton per square. Generally fibers of length 25 mm are used. Improvement in impact strength, increased flexural strength, ductility and resistance to thermal shock, used in farm work, swimming pools, decks and roofs, sewer file lines, etc. Then synthetic fibers, man-made fibers from petrochemical and textile industries. Synthetic fibers are nothing but man-made fibers from petrochemical and textile industries. It is very cheap and abundantly available, and it is also having high chemical resistance, high melting point, low modulus of elasticity. Its types are acrylic, aramid, carbon, nylon, polyester, polyethylene and polypropylene, etc. Then applications in cladding panels and shotcrete. The natural fibers obtained at very low cost and low level of energy using local manpower and technology. Its process is very simple. Then jute, coir and bamboo are examples. They may undergo organic decay, low modulus of acidity, but it has very high impact strength. So and therefore it can be used only for some limited applications. Then let us see some structural behavior of fiber reinforced concrete. So first let us see the flexure. In the flexure, the use of fibers in reinforced concrete of flexural members increases ductility, tensile strength, moment capacity and stiffness. The fibers improve crack control and pressure post cracking structural integrity of members. Then next the torsion. The use of fibers eliminate the sudden failure characteristic of plain concrete beams. It increases stiffness, torsional strength, ductility, rotational capacity and the number of cracks with a less crack. Then high strength concrete. Fibers increases the ductility of high strength concrete. Fiber addition will help in controlling crack and deflections. Then in case of shear behavior, addition of fibers increase the shear capacity of reinforced concrete beams up to 100%. Addition of randomly distributed fibers increases shear to friction strength and ultimate strength. Then in case of column, The increase of fiber content slightly increases the ductility of axial loaded specimen. The use of fiber helps in reducing the explosive type failure for columns. Then cracking and deflection. Tests have shown that fiber reinforcement effectively controls cracking and deflection in addition to strength improvement. In conventionally reinforced concrete beams, fiber addition increases the stiffness and reduces deflection. Yes. Then let us see the orientation of fibers, how the fibers are placed into concrete. So that is nothing but orientation of fibers. So sometimes it is aligned in the direction of load, sometimes it is aligned in the direction of perpendicular to load, then sometimes it is arranged randomly, it is distributed randomly into the concrete members. It is observed that fibers aligned parallel to applied load offered more tensile strength and toughness than randomly distributed or perpendicular fibers. You see that this is some kind of arrangements of fibers. The first one is, suppose the red mark is given, it is along the load direction, and the arrangement is being in the parallel direction of the load. Then another arrangements or orientation is perpendicular to the direction of the load, and the final one is the random arrangements. Like that, the fibers are being arranged into the concrete. Then advantages of fiber: high modulus of elasticity for effective long-term reinforcement even in the hardened concrete, does not rust nor corrode, and requires no minimum cover. Then ideal aspect ratio, that is relation between the fiber diameter and length, which makes them excellent for early age performance, easily placed, cast, sprayed, and less labor intensive than placing rebar, greater retained toughness in conventional concrete mixes, higher flexural strength depending on additional rate, can be made into thin sheets or irregular shapes. FRC possesses enough plasticity to go under large deformation once the peak load has been reached. Yes. Then there shall be a small comparison between fiber reinforced concrete and normal reinforced concrete. So the first one is the fiber reinforcement concrete, which has high durability, but when compared to FRC, the NRC, that is normal reinforced concrete, has lower durability. Then fiber reinforcement concrete protects steel from corrosion. Here steel potential to corrosion. Then we use the lighter materials. Here we are using heavier material, and fiber reinforcement, it was somewhat more expensive, but here it is economical. With the same volume, the strength is greater in case of fiber reinforced concrete, but with the same volume the strength is less in case of normal reinforced concrete. Here the less workability is enough, but here high workability as compared to FRC. We need high workability to work. Yes, so with this I just conclude the fiber reinforced concrete. Then in the next video we will just see the high strength concrete and high performance concrete.